Welcome back to this video tutorial. We can discuss one program example for finding whether the given number is a prime number or not. Okay, before moving to the programming, we need to understand the properties of numbers. Okay, prime number means a number divisible by itself and by 1 only. If a number is given and for that particular number, if there exist two factors only, one is the number itself and other is the 1, then such numbers are called prime numbers. If there exist more factors for a given number other than this 1 and the given number, such numbers are called composite numbers. And about the factors, we can find out one property, that is, suppose the given number is 10 and the factors of 10 is 1, 2, 5, 10. And for another number 15, the factors are 1, 3, 5 and 50. Okay, and for number 11, and the factors are 1 and 11. And for number 12, the factors are 1, 2, 3, 4, 6, 12. From these set of factors for different numbers, it is clear that 1 and the same number is factors for both the prime number and for composite numbers. And for the composite number, there exist other factors, extra factors other than this 1 and the same number. There exist some other factors extra. Okay, so while considering this set of factors of different number, while excluding this same number factor from this list, it is clear that all other factors present in the range 1 to number by 2. Correct? By excluding this same number factor from this factors list, it is clear that all the factors of this 10 comes in the range 1 to 10 by 2, right? 1 to 5, 5 is actually 10 by 2. So all the factors comes in the range 1 to 10 by 2. Okay, and here it is 15. So by excluding the same number, the remaining factors comes in the range 1 to 15 by 2. Correct? Okay, 15 by 2 is actually this division operation returns a quotient or division which is actually 7. So all the other factors 1, 3, 5, by excluding this 15, all the other factors comes in the range 1 to 15 by 2, right? And this is a prime number 11 and its factor other than the same number 11, the factor is only 1 and this comes in the range 1 to 11 by 2, right? And for 12, the factors are this, and by excluding the same number factor, remaining factors comes in the range 1 to 12 by 2. 12 by 2 is actually 6. So the factors 1, 2, 3, 4, 6 is always less than or equal to number by 2. This is one property regarding the factors of a given number. So keep in mind this. Okay, and also remember the property of prime number. Prime number means a number is divisible only by itself and by 1. Composite number means a number having more number of factors. That means the composite number have this same number factor and this 1 and extra some other factors also. And factors always comes in the range 1 to that number by 2. Okay, now we can consider this program for finding or checking whether the number is prime or not. So here we enter a number in a variable num. Now we need to check there exists extra factor. Okay, both for composite number and for the prime numbers, 1 and the same numbers are always factor. So we don't want to consider these two factors like 1 and the same number. So excluding these two, remaining factors are coming from, if there exist more factors, and that factors comes in the range 2 to number by 2. So we need to start our iteration with the value I equal to 2, and we need to continue until I become less than or equal to number by 2. and with different values of I ranging from 2 to number by 2, we need to check the remainder of this number divided by this different values that comes in the range 2 to number by 2. This is our task. And after getting the remainder, we need to check that remainder equal to 0. If the remainder equal to 0 means the divisor is a factor of the dividend. If the if the remainder is not equal to 0, then we can say the divisor is not a factor of our dividend. Okay, so this is our program. We need to divide the given number with different numbers comes in the range from 2 to number by 2, and check if there exists an extra factor. Factor means if the given number is divisible by this particular number, then it returns a value 0. By performing this modulus operation, it returns a value 0. If it returns a value 0 after this modulus operation, modulus means the remainder of this division becomes 0, then we can conclude that for that given particular number, there exists an extra factor other than 1 and the same number. That means we can directly conclude that the given number is a composite number. That means that number is not a prime number. Okay, we don't want to continue with other number division, because if there exists an extra one factor, we can directly conclude that the given number is not prime. Our aim is to check whether the number is prime or not. Okay, if there exists an extra factor other than 1 and the same number, we can directly say it is not a prime number. Okay, that is why this if condition. Here number mod I is equal to 0, we can set a variable value equal to 1. Its initial value is 0. Okay, the flag value here it is set as 1, but it is initialized as 0. If there exists, or if this condition satisfied once, we don't want to continue this for loop, because directly we can conclude that the number is not prime because there exists an extra factor in this range of I from 2 to number by 2. So we can directly skip from this loop. Okay, so we can transfer control to this position. This is actually the statement comes just after this for loop. Okay, here it is the statement of if else. If flag equal to 0, we can conclude that the number is prime. If flag not equal to 0, let's skip this if body and execute this else part. How it possible? Because consider this loop. Here there are two possibilities for comes out of this for loop. One is while if for particular I value in this range, if this particular condition satisfied, then by executing this break, we can stop the for loop body execution, directly transfer control here. Right. The another possibility is if in this particular range of 2 to number by 2, for any value of I, if this condition never comes as true, in that case, after completing this for loop execution or for loop iteration, that means whenever this I loop for loop condition become false, in that case also we need to transfer control from this for loop body to outside of our for loop body. Okay, from this it is clear that there are two possibilities for come out from this for loop. One is by executing this break statement, one is by after violating this condition. Okay, break while come out from this for loop by executing break statement means there exists one extra factor, then only we can execute this break statement. That means whenever this condition satisfied, then only we can come inside this if body, then only it execute this break statement. So before that it change the value of flag to 1, then execute this break, so directly transfer control to here. Okay, this is one case. The other cases, if never satisfy this condition, if condition for the values in the range I from 2 to number by 2, in that case never execute this break statement. We don't want to execute this if body, if for any value of I, if it never satisfy this if condition, right? In that case the for loop continue again and again, and after reaching or violating this particular condition, that is I less than or equal to number by 2, that means whenever this I value exceed this number by 2, then at that case we can stop for loop body execution and transfer control out of this for loop. Okay, so after transferring control to this position, we need to distinguish between these two cases. One is the case of executing break statement, the other is the case of violating this for loop condition. For that purpose, here it used the value of flag. Check that. If the control is transferred here by executing this break statement, in that case the flag value is 1. Okay, if the control is transferred outside of this for loop by violating this particular condition statement, that means never enter into this if body, so that never change the flag value to 1. The flag value always keeps the initialized value in that case. So flag equal to 0 means the control is transferred to outside of this for loop by violating this condition. Okay, so violating this condition means from this range for the given number there exists no other factor. So we can directly display or say it is a prime number. Okay, if the flag is not equal to 0 after this for loop body, by checking this flag value, if the flag value is not equal to 0, that means at least once this if condition is satisfied, so that it execute the break statement, so the control is transferred here, right? So from this it clear that the number can have at least one factor in this range of 2 to number by 2. In that case we can directly say the number is not prime or the number is a composite number. Okay, so this is the use of break statement, and using this flag type variable we can distinguish two possibilities, that by transferring control from the for loop body to outside. Okay, now we can execute this. Going to enter the number 12. Okay, so the result is 12 is not prime, that means 12 is composite. Once again going to enter a number 23. 23 is a prime number. Okay, this is the program as a basic program for finding the number is prime or not. Okay, thank you.